I want to talk about, so we've been hearing a lot about, product specific to how we build for scale, and what are the different methodologies, and what are the, both the research side and from the product building side, what is happening in that spectrum. So I'm trying to take a step back here and look at it from a broader perspective of what are the design decisions that we are taking here, and what are the decision how these decisions are affecting long-term product life cycle, as well as larger topics. So in the last decade, it was companies which calls themselves data-centric or completely data-driven companies that was putting out AI or machine learning solutions on a very regular basis as part of their product. But now, with the advancements in AI, and also more and more products becoming going through the digital transformation journey, ML and deep learning algorithms are increasingly being integrated into the products. So the conventional product design also needs to adapt to this. Data-centric product design, if we look in the last decade, concentrated on data warehousing, scalability of pipelines for big data, or more recently, interpretation through KPIs, dashboards, and more recently, like right now, we are in a stage where from this level of dashboards and interpretations, making business interpretations out of data, we are talking about model explainability, data privacy, and data democratization. At the same time, there is also need to look into aspects such as biases within the business, from the business point of view, as well as users which need to be built in by design into the product. So that's the attempt that I would do in the talk. So before starting, this looks at two major aspects. One is what is machine learning, and what would that mean on a product level and at scale. And the second thing is how we traditionally or currently we look at user experience. So Tom Mitchell gave the definition for machine learning as a computer program is said to learn from an experience with respect to, say an experience E with respect to some class of task T. If it performs at task T based on a particular performance measure and improves the experience E. This is a very mathematical formal definition, but the idea is that basic idea is that it learns from experience, it empathizes with the user or the people who are interacting with the system, and it improves over time based on some performance metrics. Right. So like from the mathematical point of view, even in deep learning or neural networks, things like, there are theorems like universal approximation theorem, which theoretically validates that this is possible. And so when you are putting a system to learn and on a wide variety of interesting data sets and functions, how do we make sure that or track what the system is learning? Similarly, on the user experience domain, taking these two domains as two separate things. User experience talk about what is the experience or the aspects of a person's experience when they interact with the system. So on both these tasks, also in current framework, user experience deals with the research around the product, prototyping, or creating information architecture, communicating effectively, what is the interaction, and works mostly as a separate entity in the on the product design point of view. But if we only looking at the two definitions of the of UX and ML, a few things are common. So experience, how do we learn from the experience? how do we empathize with the experience that the system is being exposed to, and obviously the human-centric part of it, right? Understanding what a feedback means, when does a person like a product or does not like a product, and so I'll try to touch upon all these three aspects as we go along. So software life cycle, whether it is like whatever be the agile or whatever workflow that we are using, typically has a approach as shown here, right? So there is need to build, and so it goes through a design sprint where it is looked at from what are the interaction design aspects of it, or what is the user experience, user interface aspects of this, and a product team that sits between a development and the the design sprint is the only communication. So the requirements are given or handed over to a development team that works on developing it, and even say there are still a few systems that evolve over time, like data products that does aggregation of certain matrices or telemetry. They there is a loop going on there, but it would still be a loop that stays within the development. So only closing of the loop that happens here would be a learning through the learning if we decide to add an additional feature into the product. But on a traditional software system wouldn't fail once it is deployed, as long as the requirement of whatever was given into the product does not change. But that's not the case with the machine learning system. So as the model is built for a specific data set, and the underlying characteristics of the data might change the model, and suddenly one day it wouldn't work, or there is typically a test case failure would not flag, or passing all the test cases does not necessarily mean that the ML model would stay in production. So looking at that more, in a ML life cycle, there are probably like two phases, where there is a POC phase where the business understanding and data understanding is a closed loop, where when we are trying to formalize the use case that is being worked upon. And then there is a model development, data preparation, model development and evaluation stage, which again forms a loop of or iterations of improving upon the model. So until recently, modeling was completely something a data scientist or ML engineer, more typically a data scientist would do. The initial ML frameworks, like even Theano or Cafe, were designed for data scientists. ML frameworks are now evolving towards more taking the example of Keras or PyTorch, they are becoming more user friendly to to software engineers. So, but the other aspect of it is the ML as a service or AI as a service has also made a lot of difference in the way these systems are being used in a traditional software engineering project. So the other aspect of this is the automation of the solutions. Auto ML is also, apart from the usage and integration of ML solutions into a normal software development lifecycle, there is also the automation of auto ML platforms that are being integrated right from say continuous development stage to the deployment. ML ops, everything is catching on, and even decisions like whether a human is required. For example, taking the example of self-driving car, so whether a human is needed or not is also a decision we are leaving the letting the system take. And yeah. So I want to go into a little bit more depth of what could be the different possible things that the ML model is being affected by certain decisions that we are taking at the design level. Now, this would be going a little bit more into the diagram that we looked at earlier. Typically, recommendation is a very most commonly or most wanted integrated tool into most of the products, hence this example. The idea is to seek to predict a user's preference. Now, the data required for a recommender system could be coming from different places, and the need for a recommendation is also a question. So is there a problem that can be solved? It would be the first question here. And take the example of a content recommendation platform. So increasing the time on the app and to determine that that's the KPI that you want to work with is a decision making at a product level. Now, in the proof of concept stage, which involves data set preparation or the exploratory analysis, a product owner would be involved, but maybe not a lot of design decisions are being taken there. But coming to the implementation design point of view, a lot of if we consider this in a traditional SDLC phase, the implementation design would be a completely technical decision. But there are aspects of front-end design, like collecting the feedback from the user. And how would that feedback improve your model over the time? So that's definitely one decision where the UX and ML definitely has to work closer, and probably not something that can be written prior to building the solution. Like it cannot be written on a design document and then go into development and never go back and check on it. The other thing would be, once deployed into the production, the performance, because ML models require continuous performance evaluation. Even certain aspects of, say, a bias observed in the recommendation need to be fixed. These are not something that you fix only at a modeling level, but also from the right from the design point of view. I mean, from the design phase of it. So going back to what we talked about, experience, empathy, and being human-centric, what would be, so if I take the example of, we stick to the example of a recommender system, what are the different aspects which comes here, right? So error, the human mind reacts to an error in different ways. So what I mean here is misunderstanding of actions. A very good an example, famous example is when an enter key and a return key are placed close by, and somebody clicks on, every time somebody clicks on the enter key, they mistakenly also click on the return button. So the user could interpret situation like this as their incapability to use the system, whereas this is a design fault. Similarly, in recommendation, when somebody is served a recommendation and which is the one which comes on as recommendation 1, 2, 3, 4. So it's on the person who uses or interacts with the system, their interpretation as to, okay, I am getting this recommendation because I have viewed certain things in the past. So this is an error that you, I mean, if that is not the case, it is an error that you're communicating to the user. In the same same situation. The other aspect is the feedback collection. So typically in recommender systems, there could be an implicit feedback and an explicit feedback. So what I mean by implicit is things that in the backend we derive based on how the user is interacting. Things like average. So in the content recommendation, number of users who have interacted with a content, time spent on a content, history of the content that the user has used in the past, so these are the implicit feedback, and we might use these matrices to build our model. The other thing is the explicit.
Adarsa, your screen is, your slides is not changed. Is it only this one slide, or is it getting changed?
Okay.
Yeah.
Is it
like there's? I thought it was a technical error. The screen slides were not moving.
Oh, okay. All this while I was just talking on one single slide?
Yeah.
Oh, okay. Okay. I didn't realize it. But okay. So I think I'll continue from here. So, so I was talking about the error and talking about, is it moving now? Like when I'm flipping between the slides? Or is this again
yeah,
stuck?
it's moving now.
Okay.
Yeah, it's moving now. We are on the second slide.
Okay.
The error, implicit feedback, and explicit feedback slide.
Sure. Thanks. So on the explicit, the explicit feedback would be things like a rating that we get from a user, or ask explicitly whether this particular recommendation is good or not. So these are again factors that would be depending on what is being shown to the user. The other large scope of things that comes under this is the biases. So I have written few kinds of biases here. Implicit bias. So implicit bias would be that which occurs when assumptions are made based on one's say mental models or personal experience as to how this would apply. So say a confirmation bias is an example of implicit bias. So where the model builder unconsciously processes the data in a way that affirms their own pre-existing beliefs or hypothesis. So there we have seen cases where a model builder has actually kept training a model until it produces a result that aligns with their own hypothesis. Or this is not a problem specifically to machine learning or software engineering, but even in other areas where experiments are done. The other reason could, the other bias, another bias could be the automation bias. So a tendency to favor, so from a user who is interacting with the system, there would be a tendency to favor results generated by automatic systems. So as a user, I'm assuming that the recommender is giving me a result which is most apted to me, irrespective of, because the user doesn't have a visibility into what is the error or the accuracy of the system, they are unaware that this need not, the results that is being shown to them need not show exactly match their history or tendencies. The other thing could be, so presentation bias is something for many years is being dealt in the UI UX area, where things like position of the content, where was the content placed on the user screen, when was it recommended, like is it at the end of viewing another content, or is it as part of a collection? So that's one. It could also be like metadata of the content which is being displayed on the scene. What I mean is, say, movie recommender system. Are we also showing along with the content? Then are you showing the name of the actor or name of the director, or is there a familiarity or appeal to the icon that is being shown on the screen along with the recommendation? Then There could also be things like whether this, say, a recommended content is already available in the device, and whether the user is made aware of it, where pop-up notifications are shown to the user, or reminders are given to a user who has a system, say an app installed in their mobile phone or through their email. So these are biases, presentation biases, which are going to influence the data or the implicit feedback that we collect and interpret or train the model going ahead. The other aspect is the generalizability. So when we talk about, this is a term which is mostly used in the context of machine learning, as like generalization would be your model's ability to adapt properly to unknown, new, or previously unseen data drawn from the same distribution as whatever is your training set. So there are assumptions about the training and test data that is inherently fed into the generalization, while there are today in, say, computer vision or in NLP models that are highly generalizable, the kind of biases, both from technical bias variance, the spectrum of overfitting, from that bias, as well as the biases, user biases that we talked about from a UX point of view. Both these things add on and becomes multiplied, gives a multiplied effect when it comes to aspect of generalization when you are presenting those results of the model to the user. So overall, looking at some of these factors that we talked about, the ability of a model to fit into a variety of function, which is basically the capacity or and in effect the scale, because you would be able to scale your product based on if it's an if you are using an ML model inside. So the capacity of the model would determine the scale to which the same product could be used for. So model with low capacity will struggle to fit into a larger user group, and vice versa. So relationship between capacity, generalization, and all the different aspects of the collecting data collection through feedback, and the error, the user introduced and the modeling introduced error, are definitely things that are going to be there when we work on building a product around any ML solutions. The other thing is the auto ML. So with AI pipelines that are being automated, the aspect of design is also inherently inbuilt by whoever is designing the auto ML platform. So it again makes the visibility of the errors and biases that we have mentioned built into the system. So in this, to summarize what we have talked about so far, there is a difference between, or there is a need for the software system development to go hand in hand, or to slowly evolve into ML system development. And while currently we see like there are products which are completely data driven and data centric, I didn't say data driven, but more as data centric. And then there are a much larger community of domains and products that are going through the digital transformation journey and being going to use ML solutions and come out as product. So from a design thinking point of view, this need to be addressed, and we need to look at different aspects. So like we spoke, continuous integration, the development practices which developers integrate code into, say, a shared repository, and we are automating even that process will this continuous integration or continuous delivery, testing, monitoring, all these aspects would mean a different, slightly different. Maybe integration might still remain the same, whereas something like a continuous testing of the model, because as the data changes, the model version in production changes. So continuous testing of models and continuous monitoring would be two areas that definitely needs to be built in into the product cycle, along with existing paradigms such as integration and deployment. So to sum up what we spoke so far, consumer-facing applications have long embraced practice of catering as closely as possible to the native intuition, but the design thinking is the lack of design thinking, or the need for design thinking, is becoming more and more noticeable in the landscape of developer-facing tools. So these including while earlier there was a bias towards, say, compilers or programming languages, currently using a human-centric framework to leverage the aspects of different paradigms of software development will help connect existing developer workflows into a more seamless experience for being adapted to the AI solutions, AI or ML solutions. So that's it from my end.